In part 3, we will combine what we did in part 1, which was about changing envelopes of operators 1, 2, 3, and 4. So please get ready with the tube bells patch you made in part 2. We will be using that as a starting point. So what we did in part 1 was to change envelopes for operators 1, 2, 3, and 4 from a simple 1 decade type to more flexible 2 decade type envelopes, like shown in this video. With the new envelopes, you will have 2 decades using rate 2, level 2, and rate 3, level 3. Press buttons 21 and 22 and use operator select button to choose an operator. In this case, you can just use operators 1 and 2 for editing. Enter envelope data shown in this table for both rate and level for operators 1 and 2. Once completed, you can copy envelope data to operators 3 and 4. Make sure to copy operator 1 envelope to operator 3. Also, copy operator 2 envelope to operator 4. When you complete copying, you will notice that the overall sound becomes softer. So, we will adjust output level like we did in part 1. Press button 27 and operator select to go to operators 2 and 4. For operator 2, set it to 82. For operator 4, set it to 79. We will check the overall sound after changing envelopes and adjusting output levels. So, by combining the algorithm interchangeability and envelopes, these new tube bells have very prominent sharp and solid attack, but it may be too much. Because we introduced the sharp attack tone by changing envelopes, the role of operator 6 can be changed. Let's think about what we can use operator 6 for. We can still use it as part of attack, or we can use it to introduce additional harmonics/inharmonics. So for this exercise, we will use operator 6 for introducing additional harmonics/inharmonics. We've already determined that operator 6 frequency ratio should be 7.00 to give sharper attack. So we will keep it as is. But what we will do is, instead of just having a sharp attack tone, operator 6 will be used just like operators 2 and 4 by generating a bell tone. We will copy operator 2 envelope to operator 6 first. Use the egg copy function to copy operator 2 envelope to operator 6. Press button 21 and use operator select button to choose operator 2. Press store and use operator on-off to copy an envelope to operator 6. Once completed, let's listen to the overall sound. There seems to be too much vibrato or chorusing effect. Let's look at the detune to find out which operator is creating too much vibrato. Press button 20 and use operator select to cycle through each operator to check its detune. You will notice that operator 6 is set to -7. You will notice that operator 6 is set to -7. When you turn on operators 1, 2, 3, 4, and 5, you will not hear the vibrato. But when you turn on operator 6, then you hear the vibrato. The tune for operator 6 is too high, so we will reduce it gradually. When you reach -3, this seems to be a sweet spot. So we will set it to -3. Although we changed the tune, but it seems there is still too much modulation from operator 6. So we will adjust output level. Turn on all operators so we can change operator 6 output level to find a sweet spot for the overall sound. Press operator select button to go to operator 6. At the moment, operator 6 output level is 65. We will lower it slightly by 1 increment. "63 seems to be a sweet spot, so we will set it at 63. We use the Tube Bells patch from the Part 2 tutorial. We change the envelopes of operators 1, 2, 3, and 4, just like in the Part 1 tutorial. We adjusted output level of operators 2 and 4, just like in the Part 1 tutorial. We adjusted envelope and output level of operator 6. So, what do we need to do next? We need to look into key velocity sensitivity for giving the Tube Bells patch its expressiveness. We know that the original Tube Bells patch is a bit lifeless, as key velocity sensitivity is only applied to operator 5. Press button 28 and operator select to cycle through all operators. So we need to set the sensitivity so that when you play soft, it sounds soft with less harmonics/inharmonics. When you play hard, its sharp attack becomes prominent and the overall sound becomes rich in harmonics and inharmonics. So how do you set it? We need to think about the relationship between carriers and modulators. This means that set key velocity sensitivity of modulators higher than that of carriers for great harmonic content dynamics. I'm showing this table as an example of how I will set key velocity sensitivity. Note that operators 1 and 3 have less sensitivity than operators 2, 4, 5, and 6. This means that when you play soft, modulators produce significantly less modulation, hence the sound becomes very soft. Operator 5 is set at 3. When you play soft, you will still hear a soft hammer tone hitting a tube bell. Finally, we've made the tube bell sound with an expressive sharp and solid attack tone and harmonic rich overall sound. Let's compare this to the original patch. Once you hear this great improvement that we've made, we can't go back to the original, non-expressive sound. You can play harder or softer, and the DX7, despite its 80s technology, faithfully recreates the amazing tube bells sound in real time. What we really did was to fully take advantages of the DX7 FM synthesis by creating sharp and solid attack and harmonic rich tone with greater expressiveness. This is what the DX7 was designed for, using its FM synthesis to generate realistic metallic sound. We changed the algorithm by applying the algorithm interchangeability to create an additional modulator which gave us more flexibility and options in FM sound design. We changed fixed frequency and frequency ratio to generate a hammer tone and sharp attack as well as additional harmonics. We changed envelopes to get right balance between sharp attack and additional harmonics. We changed the output level to get a right balance of modulation from each modulator. We changed key velocity sensitivity to create a sound with greater expressiveness. You can pause this tutorial video for self-learning tutorials. You can think about what else you can do to make further improvements, especially focusing on priority parameters. You can change operator 6 frequency ratio to find other ratios that may be useful. You can also adjust key velocity sensitivity to create a different expressiveness. Also, you can think about whether changing low priority parameters will make a big difference in the overall tone. Does LFO make a difference? Can we use keyboard level scaling to adjust overall tone from lower to upper notes? Now, we finally completed our journey with the Tube Bells patch. And I truly thank you for joining me with this journey. If you've watched all of my tutorial videos and followed my instructions, as well as doing self-learning tutorials, you've actually achieved so much. I've applied many years of my painful experience with the DX7 FM synthesis to create these tutorials. So you're learning proven, practical, and hands-on approaches to tackle the often misunderstood FM synthesis. You've actually learned how I approached FM synthesis sound design from the beginning to the end. You've learned to analyze the sound using the FM synthesis, think and plan improvement ideas, make improvements using the DX7 envelope generator, algorithm interchangeability, and other priority parameters. You've learned to make changes and adjustments by going back and forth between interrelated priority parameters. You've actually made 3 different tube bells patches by exploring different possibilities and combining various techniques. At the end, you now have the best foundation to learn and tackle one of the best and challenging synthesis method, the FM synthesis. So, congratulations to you all.